CLion, a cross-platform IDE for C and C++. Download now.
Hello, everyone. My name is Mateusz Pusz, and I'm an addict. I'm addicted to writing, developing C++ generic libraries and frameworks, and this is what I do for most of my professional life. Some of you may recognize me for my MP units work. When I work in quantities and units libraries, I have been speaking about this for a few years right now. Today, I will not be speaking about units per se, although you will see some examples of that, but I've did many other libraries and frameworks through my life. Initially, when I submitted this talk, I actually planned to talk about 10 essential features that are lacking in the libraries, but I ended up with, strange, what happens, with 16. So there's a bit more. There's a bit more to talk about today. C++ evolution. Through the years, C++ was getting better and better. I always say that C++11 is a cornerstone of modern C++. It provided move semantics, provided context, provided lambda expressions, variable templates, more modern threads, range for chrono. Without most of those features, you cannot imagine modern C++ today, right? C+20 was huge. It added concepts, ranges, coroutines, class NTTPs, context, all the things, right? Const eval, new opportunities to do compile-time programming, space operator format, and plenty of new concurrency stuff. Well, and we got modules, right? Yeah, in 20. Now, we are preparing for C+26, and it's going to be awesome. Again, we'll have contracts, we'll have state execution, we'll have even more context, even though we context all the things before already. We'll have relocability, RCU, hazard pointer, SIMD, lineage, and hopefully reflection. I'm saying hopefully because it's accepted by the design, but it didn't pass the wording stage yet. So hopefully in Sofia, in the next meeting, in June, I think, we'll be voting this to the standard. But still, there are many features that are missing that would allow us, library developers, provide better experience to our users. I will talk about many features and problems that developers face today. I will talk about improving interfaces. I will talk about enabling compile-time code debugging, better compile-time error messages, improving safety, need for additional text utilities, and how we can improve distribution of our products to our users. The feature list is, of course, subjective and far from being complete, right? Because there's plenty of features. Everyone has their own favorite features. Me, as a library developer, I have my own. I'll present how those problems can be addressed with future C+ language and library features. When I actually submitted this talk, all of this was future. However, on the last meeting, we accepted some of those for the standard. So they will be in the future, but they are right now it is a known future rather than unknown future, because they are already accepted. So the things that are already accepted, I will be marking as C++26 in the title, so you can easily find and make sure that you can expect those to be in the next release. If it's still in the pipeline, then we'll have no annotation. I will also talk about some papers that were abandoned during the process, and they are waiting for someone to pick up. So in case you would like to help, you are welcome to join and help us with that. I will not discuss any big features in detail, like reflection contracts. Those are awesome, but we don't have much time. I want to talk about many other smaller stuff. There are plenty of great talks about those already. I'm actually quite amazed that there are not many reflection talks on this conference. Everyone talks about synthesis errors, coroutines, which are awesome as well, but I expect actually there will be plenty of reflection talks, but I didn't see much. Yeah, we don't have enough time for that here at this talk, and many great talks are already available online as well. However, I provide concrete examples of how those features can be used to solve our problems in modern C++ libraries. I will be referring to papers, so the standard proposals. You can find the paper if you don't know how to do it with this WG21 link. You can specify the P number with specific revision, or just P and the number. It will always provide the latest revision for the paper. You can also check actual status on GitHub about this paper. What's the process? What was the last polling, voting on this? So it's useful. You can also get the latest working draft with this syntax, or you can just take the more information and user info by just passing the link. That's a useful tool that we have to actually find papers. And let's move to the first chapter, improving interfaces. I will rewind a bit to my talks that I provided before, because I want to stress some specific concerns that I have. How do you feel about this interface? I've heard awesome from the audience. Some people say they want to be sick, right? There was a nice comment saying it's a future-proof interface. Yes, it type erases all the things, right? All right, so we have plenty of love from this interface, right? There's a C-like coding. We not like to do it. We have strong types in the C++ language. And then we write code like this one. Or this one, which with C++ actually can be written that way. Or this way. Is it really better? Well, it will fail at compile time, not at runtime, right? But from the interface point of view, from the design point of view, from the documentation point of view, it's not much better, but we are used to writing this all the time. And we still do it, even though it's 2025, and you have tools in the language for 5 years already, right? So I want to stress it really, really hard today. Unconstrained template parameters are the void star of C++, right? So this is legacy template code. My library could be written this way, right? I will have some auto, some type name, some auto, some type name. I return some auto. But then, as a user, I always have questions like, what should I pass for R and rep? If it doesn't compile, is it my fault or is it a bug in the library, right? What if rep can be divided by rep2, right? Because this is a division operator. What is actually returned from this function? I've seen plenty of developers overusing auto everywhere because it's less to type. Even me, as a trainer, I often say to my students, be lazy, but this is being too lazy, right? Be mindful for your users. You don't want to see auto as a return type for all of the algorithms in standard library. If you think it's a good idea, we can talk about this in LWG, but probably you don't want to do it, right? You expect others to provide return types, but some of us do not provide return types to other users. Don't do it. My statement is this: if I will manage to crash the compilation of your code after C+20, of course, then it is your bug, not my issue. Because you should provide proper interfaces, so I am not allowed to enter your code with invalid type. And I have to advertise those requirements in the constraints of our type. But before I show you the constraints, I want to ask you, can you spot a bug? Actually, there is a functionality issue here in this operator. We wrote plenty of code like this in our code bases, but this code is surprisingly behaving in specific cases. The problem are the arguments of the operator. This one is non-dependent. This one is dependent. They are different rules, conversion rules for both of the parameters, right? With non-dependent parameters, you have typical overload resolution process, right? So you have trivial conversions, promotions, standard conversions, user-defined conversions. For the dependent one, you will just have parameter adjustment and conditionalization of alternatives, which involves only derived classes. So you'll be able to pass a derived class to it, to this one, but anything that will convertible from or to quantity will not be accepted by the right-hand side argument. So maybe for division operators, not a big problem, but consider about operator plus, that will not be commutative, right? So those are the things that actually often happen in production as bugs. Just as a side note, maybe. I talked about this during my friend talk this year as well. So how to constrain that? With constraints, well, it gets verbose, of course, but it also gets plenty of information to the user saying, this is how I want to use. We have to pass something that's a reference, something that's a representation of something that's derived from quantity, because with derived from quantity, I actually made both of them not convertible, which basically is the same property on both sides, right? And I also want to make sure that I can invoke the division operator on those two. And I'm returning some kind of quantity. It's always better than just pure auto. Right? So challenge every naked type name and auto in your code. But that's only half of the story, half of the picture. This is compile time part of the picture. There's also a runtime part of it that we had AC+20 for a few months, and then we decided to remove it. Those are contracts, right? 5 years later, we still are not allowed to put contract requirements, contract specification in the signature of the function, right? Macros we provide, hopefully we provide those macros, because sometimes I don't see them. Macros that we provide are not visible in the declarations, are not visible in the documentation generated stuff, in API references. So even though they are hopefully there, you don't know that it's actually the interface and requirement of this function, right? So I cannot stress it, and this is only typically checked at debug only. I cannot stress it more. C++ contracts are awesome, and I will not talk about them in this talk too much, but this is groundbreaking stuff in providing safety and good interfaces to our users. Right? There was a great talk by Timur. If you didn't see that, there will be online version soon, right? Contracts are awesome. And being able to specify compile time and the runtime properties of your interface is really, really nice. So this is the first of our features, and they already in C++26. They were voted in and accepted by this WG21. Next thing that I would like to talk about are non-type template parameters. In 2020, I said that usage of class templates as non-type template parameters might be one of the most significant improvements in compile time template metaprogramming during last decade. If a template parameter behaves like a value, it probably should be an NTTP. At this point, I even didn't recognize how much I will need that. I just expected that would be a thing, but at this point, my MPUs library did not use them too much. But then I came up with version 2. And in version 2, this is how you specify stuff. This is how you specify dimensions. This is how you specify so-called quantity specifications, so types of quantities. This is how you specify units, all in one lines. You can specify also prefixes, and then write quantity this way. All of the highlighted things here are NTTPs. There's no single template parameter nearly on the slide that is not an NTTP. This is so awesome and so useful in many places, right? We can specify text. We can do operators in template parameters, like here and here. Or we can even use this syntax to specify this is quantity of speed in kilometers per hour. It improves the readability of the code and usability of the code a lot. So the rules for NTTPs right now are that the types that are invoked have to be structural types. Structural types is a scalar type, a value reference to a type, or a literal class where all base classes and non-static data members are public. So let's see another example where I'm defining dimension for thermodynamic temperature, quantity for it. I provide an absolute 0 as a point origin for our scale of kelvins, and then unit of Kelvin that uses this origin to specify Kelvin's scale of units. And then I say that I have some delta being 273 millikelvins. I can specify this as a point, absolute 0 plus delta. And I can specify ice point based on this. And degree Celsius, also using this ice point here as an origin. With this, I can write room temperature with 21 degrees Celsius. But where I'm heading this is something bigger. This is quantity point is using quantity, and then I'm passing this quantity point, known as compile time, to our definition of ice point, which is then used in the definition of degree Celsius. So they're not like simple types only being used there, but also smarter classes that you can pass to templates and use them efficiently in your code base. But there's a side effect. Side effect is that users can do this. So they can access my private members, my implementation details of my types, because of the requirements that all members have to be public. So I'm making this really hard to actually abuse my types and manipulate the value and scale the value, but I have to basically to export to provide all of the members publicly in order for this feature to work at compile time. And that's an issue. Actually, I've found already use cases where some people refactor the code from the function to using a member, using my library, because for that time I'm just searching GitHub how people are using my code. So I found this pull request in the user's code base. So I said, please don't use member data directly. This is implementation detail and should not be used directly. It seems I have to obfuscate the name more to discourage people from using it. Well, obfuscation would probably be not effective. Provide maybe the shouldn't comment or whatever, because IDEs will provide the name anyway. If I pass dot, I will see the member, no matter if you type obfuscation or not. So I did both. This is what I have right now in my code base, but it's still public. And I'm using this member everywhere in my class right now, right, with the long name that I hate. So the impact of the restrictions on NTTPs. Authors of C++ classes that want them to be usable as NTTPs have to sacrifice encapsulation, right? Also, plenty of types that could be useful in compile-time programming is not allowed because they historically had private implementation. And we cannot switch it right now to make them usable at compile time. And for sure, we don't want to have tuple2 and variant 2 and optional 2 just for NTTPs. Right? Also, my quantity right now, as you've seen, is compatible with NTTPs, but if someone will use a representation type that might use private members, my quantity will not be able to be used anymore, because members will not be NTTP friendly, so my type will also be not NTTP friendly, even though it has public member. Also, there was a proposal by me to have a basic fixed string for C+26, and it was basically rejected or postponed because we hope to have an in-place string instead. But in-place string, as of today, can't properly work as a structural type. So we didn't get fixed string for C+26. We'll see what we get in C++29. The solution for this actually is on the pipeline, but is struggling to actually be accepted for a longer time. Actually, LEWG last time was scared of this proposal when we see this in Austria. The solution to make this work would be just have all of the members private and specify that I have two functions, to meta representation using basically reflection, and from meta representation using reflection, both equals default because compiler knows how to implement this in this simple case, and this would be all for me to write it. So this is proper NTTP, and most of other types, like tuple, optional, will have to use similar pattern, which is also really, really simple. And this immediately makes them NTTP friendly with this new proposal. So having this would be really nice. As I said, NTTPs are really, really something huge, something new, something that we should more experiment with in our software, because they open the doors to new syntaxes, new opportunities to our users to have better experience with our code. If you want to learn more how it works, go to the paper and read, because due to the constraints of our talk today, I don't have time to actually explain how those features work, but I want to show you how to use them in order to fix your code bases. And if you're interested about any feature, just find the paper number and read more about it if you are interested. I just want to raise attention to those papers so they will get more attention and more, basically, maybe they will be easier to progress in the community. Next thing, this code does not compile. Do you know what may be the problem? Right, universal references, 4-degree references, right? Those are for perfect forwarding, so they tend to have additional qualifiers, right? Like const, volatile, or sometimes references as well. And probably my concept is not smart enough to actually say that reference is actually a quantity. So it doesn't work, right? So what we have to type? We have to type this. If you want to write an algorithm 1.0 for array tables, I write that takes a range, and each range value has to be an array table. Right? So there are many cases where actually only the shorthand or the shorthand or test notation is not enough to spell the interface of the type, because we need to provide additional constraints. Another thing is that I may have this variable template. Variable templates are great as customization points. They are really fast to compile and less to type comparing to class templates. So many frameworks, including ranges and most modern frameworks, start to use variable templates for customization. But then if you want to actually write something like all of that takes predicate, you have to pass a type name here, because the C++ language only supports templates for classes, not for anything else. So if I happen to already have this predicate as a Boolean in my code, I have to actually introduce a class template based on this predicate to pass it to my all of, which sucks. Right? This is more to type, extraneous abstractions that are actually not needed for anything else, and slower to compile. With the new proposal, 2841, we can use concept as variable templates parameters in the language. And this is accepted to C+26 as of the last meeting in Austria that we have, in Hagenberg. Before we had this one, now I can write a concept called dcase2 and pass a concept as a template parameter. And with this, my previous line is just full dcase2 quantity auto. I don't have to spell 2 lines anymore. Of course, dcase2 and remove cvref works a bit differently, but I didn't have a good name for remove cvref in this for this concept. But in this case, it works exactly the same. I mean, for the quantity needs. Another one, I had this one all, right? I can write a concept called range of and pass it again concept template and say range and then apply concept to the value of the range. And then my when all becomes this, range of array table. Again, much nicer interface in my opinion. Less to type, easier to read, right? Regarding variable templates, I was actually, let's say, complaining for a long time. In 2021, I actually said that I would love to actually use here variable templates for some stuff. Like, for example, value pi being passed to a template parameter, because we already have pi. It's not a class template, it's a variable template in maths, right? And then if you would like to use the class template, you have to wrap it with a class template, because otherwise you cannot pass it to a template. So actually I wrote the first proposal about this, but then contributors took over and finalized this paper, because I didn't have enough time to actually do it by myself. I was doing MP units all the time. So we had this all off before, right? With additional class template. Right now I can write all off, taking auto predicate, and then I can pass my variable template right away, which makes the compile times faster. I don't need any other additional abstractions here, which is really, really nice. All right. But before, after. Why do I have to choose? Why can't I have both? Right. And now we are coming to template parameter kinds. Language specifies there are 3 kinds of parameters. You may have types, non-types, or templates. And that's it. You have to specific. You have to specify one of those parameters, one of those kinds, every time you specify a signature of a template. Right? Because this is a part of signature of the template. Template signature has number of parameters, and they are kind, one of the 3 that we have. And then hopefully we also have here concept and auto, as we've seen, instead of type name as well. So if I want to write all of for everything, this is what I type. This one takes type name templates, also class templates. This one takes variable templates. This one takes concept templates. Nice, right? But that's not it, not everything, because this is just for types. I may want to pass values and have values being here in our class template, being in our predicate being analyzed. So I did more. And then I think, OK, I'm done. But at some point, I think, oh, actually, someone might want to pass an auto, but predicate with a type name. So I need to do actually decl type on this, and this will also work. And I think, now I'm ready. I've written truly generic code, right? Everything is covered. Maybe it's a problem to actually understand those names, this pattern. This is the type of the predicate. This is the type of the value. But now I covered all of the bases, right? I'm so proud of myself. And then a user comes. I want this code to work as well. And this is me. Right? That's a valid request. I want to check if all of those are integral. If I pass you type, just check the type. If I pass you the value, just do decl type on this and check if it's integral. Why not? And with this, I have to give up, right? Again, for quite a long time, 2020, I'm talking about universal template parameter kinds. I provided the first version of the paper, which again, I didn't have time to continue, so I got really great contributors and then authors of the next proposal that actually is in the pipeline, but still not accepted. This means that we are introducing a new template parameter kind that will allow us to say, I don't care what is the kind of the parameter, it's just a parameter, like a base class for all of them, right? I cannot do much with them besides dispatching them to specific kind, but I can say here, this is all of. It takes a template that takes anything and generates anything, and basically arguments of anything. This was impossible before. And then I can say, OK, so I have some check for each of those checks here. So the check will also take anything and return anything. And then I have special condition here saying that in case I have a predicate taking types, but I pass values, I will do decl types on those. And then my check implementation says just apply predicate and argument unless you are a type name generator, so class template, then just do colon value on this. And with those simple five lines, I wrote really truly generic code that works with everything. All right? So thanks to this, you can write things like is specialization of, where you can say this is always false unless this is actually specialization of my type, provide a concept for it, and then it works. I can check both if it's a specialization of vector, but also of array. Array has type and non-type parameters, right? Because there is t and size. So typically, you will not be able to write it right now in the language. Another useful concept, derived from specialization of, written similar way, and I can say that my, for example, quantity is derived from, or the type is derived from the quantity, which is also very useful. I could do range of, where I can pass range of away table, like I said before, but also range of int as a type, with the same concept. Plenty of new opportunities to actually write better generic code. I also showed this example some time ago on my talks, maybe not visible here too much, but I showed that as we have specific kinds, I have to actually name every class template specifically with long name for a unit, depending on what parameters it takes. With universal template parameters, it's more like function overloads. They have exactly the same name for class template, and just the parameter differ, right? Because I can say in the initial implementation that I'm having generic number of parameters, I don't care what they are. So useful. So universal template parameters, in my opinion, are truly a cornerstone to build truly generic interfaces. They still didn't pass through evolution working group, but I think this is really, really important stuff in order for us to provide better interfaces, better experience to our users. As you said, customization points based on variable templates are less to type and faster to compile, so they are recommended in every code base. This was what I showed, treated as floating point, right? I may have treated as floating point, just is floating point v in the initial implementation, and then provide specialization for my save type saying this will be also floating point if t is a floating point. Fine. This worked great, but sometimes I have to write something like this. So I say this is superscript number in UTF for 0, 1 to 9. Fine, but what to provide in the primary definition as an answer? There's no good default answer in this case, right? So sometimes they are not good fit as of today. But there's another interesting proposal called template equals delete, where actually you can say there is no primary definition, only specializations. This paper is abandoned. I think it didn't have any major revision for the last 4 years. So in case you would like to contribute and help progressing this, you're welcome, because this is also really useful to actually use variable templates in such contexts. All right, another use case. I want to implement latitude, longitude. I specify them as quantity points, measured in degrees, from equator and prime meridian, and bounded from minus 90 to 90 and minus 180 to 180. And they call it a position, latitude, longitude, right? Using strong types everywhere, not just double. And I want to calculate spherical distance, where I pass those positions. I take the latitude from longitude from the structure. I measure the Earth of radius of Earth, and then do some calculations. Notice that I have to provide this using directive here, declaration, using declaration, even though I have the SI namespace in our type. So ADL doesn't work. It turns out that ADL says that, well, ADL basically is the set of things you are using during, basically ADL looks for the names of arguments in namespaces provided as arguments to the function call. So there are so-called set of 0 or more associated namespaces to be considered in this case. And the rules said explicitly that they are specified in the following way, that in case of a class template specialization, only template type parameters are involved. And there's even specific note, explicit note in the standard saying non-type template arguments do not contribute to the set of associated namespaces. I really don't know what was the rationale for it, but this is a really long, old note, and this was never changed. So because of it, I have to write this using declaration everywhere in my code, and this is what I said in one of my talks, saying that I can either write quantity of SI meter divided by the SI second, which is nice syntax, usability, but ADL does not use namespaces of those arguments. Or I have to write quantity decal type of SI meter, SI second, which I assume no one of you would like to write in daily code. But this will enable ADL, but will be really have bad syntax. And I asked why so often we can't have nice things, right? And then Matthias Kretz came with a proposal to LWG called constant wrapper. And it turns out that he has nice things. That's what he does. Really? So basically it takes non-type parameter as the first parameter, and then it decal types it to some unnamed parameter just to enable LDA lookup for that. Well, it somehow works, but I'm always concerned about the readability of my error messages in quantity libraries. I don't want the unit to be duplicated twice in the type. Once for the value, second once for the type, right? Because it will just make everything so much longer and harder to reason about. What is a quantity of second and second, right? And it may be actually longer type if you do some derived units there. And actually, even Matthias in his paper says that, of course, this string insertion here will not work without the unnamed parameter because we'll not be able to find this namespace associated with foo. But he also says that basically this is imperfect because if you are having something that is passed here as a type, but it has NTTP by itself, it will not work anymore. Because this thing, this string-lit, whatever, so string literal will not use this hack to enable this value here to be, again, NTTP friendly, the ADL friendly. So this is not the best place to be there. There is a paper, a proposal that proposes to improve that, again, still in the pipeline, where actually you can fix that by specifying explicitly which namespaces are treated as associated namespaces to your type. And here you can say, those are namespaces of declare type X. Declare type actually, probably I wanted to write something else than X, right? R, declare type R. And this will just add those to the namespaces here. You may improve compile times in sender receivers by saying then sender does not have any associated namespaces. There are plenty of hacks being done in the sender receiver implementation to actually limit that with some programming practices. But with this, it would be so simple, saying, well, don't look for anything, right? If you have some additional sources and functors from the users senders here with some other namespaces, and if you know sender receivers, the types are huge. You can express entire program as a type, and the type will be as long as a Bible, right? So you have all of the namespaces there in a type. So all of the namespaces will be always looked for everything, which makes it so slow. With this, it will be so simple, saying, no, just don't look into them. Or you can narrow down stuff, say this is array map. Array map by default takes stud allocator of t, but doesn't mean that I want to look for namespace stud for all of the overloads. Don't do it. Just take the t namespace associated with it, right? I don't care about stud because of the allocator being used for the array map. A really useful feature, still in the pipeline. Another interesting case that I have in my library, I have to sort the type. So no matter how I do the multiplication, either kilogram, meter, or meter, kilogram, I want to end up with the same type. Otherwise, it would be nonsense and hard to reason about in the generic code. The type is actually really nice to read, I hope. Derived unit of kilogram, meter. Nearly exactly what you have typed here. How I'm doing this? I have expressionless that takes some predicate and 2 parameters. And then I provide the implementation that basically inherits from this predicate with those parameters. Quite simple if you know a bit about generic programming. And then what I provided as a predicate? Well, I have a function type name, right? And for type name, I said that this is basically bool constant of type name on the left-hand side, of the type name right-hand side, and this basically will be my predicate to be used for expressionless. Type name, of course, is written this way, right? This is not standard hack, but works in many cases. So this is the case that I have right now. But then, for example, I have noticed that I'm having an anonymous namespace where I specify my custom unit, and I measure cows meters, right? And then cows meters on GCC will be this type. On Clang, I will have this type. It might not be that hard, but still it's confusing, especially for unit testing. If you want to unit test that, which is what type is being generated, I have to have branches or do some other practices in order for different compilers to have the same type being generated. So there is a really nice proposal. Actually, I think that it is accepted by evolution, but still didn't pass plenary. That is called standardized context type ordering. Basically, there will be stud type order as a predicate, and that's it. You don't need anything else. And this will allow you to provide canonicalized typesets, for example. If I pass typeset AB or typeset BAA, I will get exactly the same type. Or canonicalized policy-based libraries, right? If you're having policy-based libraries mixed in base libraries, you don't actually care if the user will type all of the parameters in the same order or different, right? If I will pass iterable and ostreamable in this order or another order, I'm having exactly the same property of the class. So why to instantiate all of them in our code base and basically make the binary bigger and all of the resolution potentially for ADL larger? If you could basically order them and then deduplicate them, it will be much easier to reason about, because users may also accidentally duplicate the same property twice, right? Or variant, for example, is being used in sender receivers in many places, automatically generated from values. If it could be canonicalized again from the parameters, then you will always have the same variant being used, which will again mean less instantiations, faster compile times, and possibly ADL also faster. Really interesting and important property. May look like a small feature, but improves daily life a lot. When I provide trainings to my students, I always say, always use constructor initializer lists. This is a good rule of thumb for the design. But then I have a measurement class, which has a value and uncertainty. And value, of course, I can just apply here, but I cannot do uncertainty because I want to benefit from ADL for ABS lookup. So I have to use constructor value to initialize it, which sucks. Also, if I'm implementing things like ABS in my library, I have to say that I'm calling it MBS only if I can call it either with unqualified lookup through ADL or with std ABS. Because I cannot use using namespace in the constraint check. And of course, I have to provide this using here in order for this to work. There are many of other tools, many other types from the numerics library being developed right now. CMD, quantities, possibly safe numeric types, safe floats, safe ints. A lot of work being done on this one, right? And everyone will struggle with the same issues. How to make ABS work in generic context, in generic code. Maybe we should need and get CPOs for mathematical functions. Would increase interop between different various numeric related types. There's no paper for this, but basically doing this is quite simple, right? You provide your own constellation point object that actually can check plenty of things, right? So I have here the ABS constellation point object. I provide the type for it. Before I provide the type, I have the inner namespace with the poison pill to make sure that the ABS lookup will not go out of this namespace. So I'll just use ADL rather than the scope resolution to find the ABS. And then I calling core operator only if one of those compiles. I'm checking for std ABS, and I'm checking for the ABS member and ABS non-member, which already extends the interface that we had before. And I also making sure that the answer, the result of this is non-void, because, well, what does it mean for ABS returning void, right? It's just some function that coincidentally have the same name that we expect. And then with simple context branches, I just do the correct thing, right? With the members, with this check, I actually do more than we did in the previous exercises, because probably no one would like to write all of those in their own user's code, those checks. But doing this once correctly will provide std ABS to everyone. And then instead of writing this, I can write that. And it will be easier for everyone to just work with that. Writing the proposal may be quite lengthy, but really easy from the technical point of view, because writing the same wrapper or similar wrapper to all of the math functions will be just lots of typing. But from the technical point of view, actually, it's quite simple. And I think it will be useful to have it. All right? All right, but let's move on. Enable compile time code debugging. Traditional debugging of const-exif code is hard. Debugging of const-eval code is impossible. All right? When I have this function, const-eval, and something doesn't work, this is me. It's really hard to find out what doesn't work if you don't have a binary of this function in your project. There are some proposals that could help with that. There's a proposal called emitting messages at compile time, which actually allows you to put prints that will be visible at compile time in the compile time log that you actually took some specific branch here. Moreover, it provides us a possibility to specify a tag that could be enabled during compilation by some compilation-specific interface that allows us to enable those. So I can selectively enable only specific prints that I'm interested in at compile time. And this is not only for that. For example, this format code is correct. It's surprising, but it's correct. Right? It has to be correct because in case of translations, some of the arguments may not be useful. And depending who you are, you either do that, because I see some scared faces here, or you may be just, say, oh, it's interesting. If you are a nerd, actually you are this guy. It's like, oh, that's interesting. Or you may be this guy, right? But yes, this is correct code. But however, most users probably would like to diagnose such issues in their format strings. And they can use it with context warning string. So not just print, but also warnings with specific tag. And moreover, you'll be able to use W and WNO parameters, for example, in command line to specify this warning, specified by you in the code, to be triggered or not. Again, a really nice feature to help you with compile time stuff. And of course, if you have print, if you have warnings, we also have errors. Right? So you can also generate a compile time error with this feature and print a message. And this leads us to the next chapter of better compile time error messages. Right? During this conference already, we've seen a lot of talks where people were complaining about compile times and were wondering how we can improve that. And I said, come to my talk on Thursday. So here we are. My quantity. Quantity type basically has reference, representation, and I get those types here. I have reference, quantity spec, unit, and some representation. And then I have an in function that will allow us to convert a unit from one to another. And they provide a concept, unit compatible with, and specify, basically compare if the new unit is compatible with the previous one and the quantity type we use. And also check if the conversion is value preserving for specific representation type from specific unit to specific unit. If I will provide something, some nonsense, saying I want to convert meters to time, so to a quantity, not to a unit, the first check will fire, will say basically time is not a unit. Really nice error message, in my opinion, short one. This is all. I'm not cheating. So only a few lines with a really reliable error messages. So concepts actually can provide really nice error messages already. If they are not, it means that sometimes someone is doing or using them incorrectly. If I provide something more advanced, like in this case I'm providing proper unit, but of a different quantity type, I will say still that no member function called because constraints are not satisfied, because unit compatible with evaluated to false, because what's happened here? Yeah, unit of seconds, it's not a unit of length, right? Evaluated to false, because this is not implicitly convertible. Second to length will not be convertible properly. Still quite nice message. Although there is something that bothers me in Clang for years, I submitted bugs for it, but still it was not fixed. Actually, we have a local nerd competition in our quantities project to find out who will be able to generate the error message with the most curlies generated by Clang. If instead of that you will get that, it will be much better. Right? And this error message is short and nice to read. Or another case, while actually passing meters and kilometers, I will get information that constraints are not satisfied because value preserving evaluated to false, because int does not satisfy its floating point, and there is no integral conversion factor between units. From meter to kilometer, evaluated to false. Again, entire error message. error messages can be nice if you're using a correct compiler. This is GCC. With GCC, you have a longer message. It's hard to reason about it. It says that controls are not satisfied because, well, this junction failed, but you don't know why. If you want to know why, you have to enable fconcepts diagnostics depth equals 2 or 3 or 4, and this will split more pages of errors for you, saying basically what's wrong. So I would say that GCC is a bit behind with concepts comparing to Clang, but still you can get error messages. So how it's implemented? I have those concepts, unit compatible with and value preserving to here for our in, as we've seen before. But let's play with this a bit. I will leave the unit constraint only, saying that I still want to check if something is a unit or not for overload resolution problems. But for the rest, I will provide nice error messages to the user. This is incompatible unit, not value preserving. All right? With static asserts. So I go and do static asserts. And they have really nice error messages saying in the very top, not value preserving. And even in the latest releases, Clang will provide me information why it's failing. Not just it is failing, but why, because it analyzes the argument and says exactly why the argument failed, which is nice. So you have information what, and then followed by why, which is quite nice. There is a proposal that was accepted in C++26 called user-generated static assert messages that allows you to actually provide a custom string to static assert. We cannot do static custom strings at compile time right now with format. So I'm using FMT, format 2, and this is how you can do context format. Just have a string, do format 2 to the string with back inserter, and you are done. And then I can type static assert with context format, unit is incompatible for, and conversion from is not value preserving. And this is what I get. Conversion from meter to kilometer is not value preserving. I would say this is awesome error message. Right? Lots of improvement. And actually, there's another proposal saying, let's make stud format context. And then you can type stud format here instead of this FMT dependency and all of those like FMT compile hacks. And even more, you can use reflection, that I will not talk much more here, but reflection is awesome. See other talks, where you can actually get the type of our representation and put it here. And I get an error message saying conversion from meter to kilometer is not value preserving for int representation type. I hear, yes, I did take my money here. Yes, exactly. But there is a caveat here. There are some dots and error generation. I have another error saying no matching construction code here. And 129 lines more. So it's not that concise as you would expect, as it was before. What is the reason? Because, well, the compiler still tries to determine what's the return type of this function. So it tries to call this constructor after static assert. And this constructor, of course, fails because it got incorrect input. That's why I had those checked before, so I will not provide incorrect input to my constructor. All right? So there is an issue. This is the first issue of static assert. Second issue is that some users may want to write something like this. Try convert to. They provide quantity and unit, and they say, I have kilometers. Try convert to kilometers. If I can, return this. If not, just return the original quantity. A static assert will fire, and I will not be able to do that at compile time, because static assert is not SFINAE-friendly. And this bothers me for a long, long time already. In 2023, I actually provided an issue to one of the repositories with co-author sitting here in the room that basically used static assert in the template instantiation error. And this library will basically checking the static assert if for some specific linear algebra vector type, if we basically multiply stuff, if we'll get proper columns. So this is a valid check. But this valid check actually fires for me in such a line here. I'm checking if I can do v times v divided by v, I'm using this type. Otherwise, I'm using int max. And they should be able to do this in generic code. But the static assert like this one prevents me from checking that. So static asserts are really not good for compile time error message generation. Another use case. If I will start the static asserts in my in function, I would not be able to unit test all of invalid conversions in my unit tests. Because in my unit test, I actually have a concept called invalid unit conversion, and I check all of the invalid combinations to find out if my concepts work correctly. With static asserts, this will not work again. All right? So I would claim that introduction of requires expression in C++ 20 made it so easy to write generic, safe, and nice code for the users. Everyone can type it, because using void t before enable if was really hard. Right now, everyone can benefit from this. It's so easy. It will be more and more coding using trees like that. If you keep using static asserts in your code, this will not work for most of the people. So static assert is really not good to provide proper diagnostics at error time. They're good for asserting stuff, like C assert is, but this is not a proper solution to print nice error messages, in my opinion. You can either right now you have to deal with concepts, or emitting messages at compile time that we discussed so far, but this, again, is not SFINAE-friendly. And there's also an upgrade that waits for concepts to functional format to be accepted, where actually concepts error string will have an overload for FMT-like syntax, when FMT actually is concepts in the standard, so it will be even easier to write those. But those are still for like tracing, for like debugging, in my opinion, rather than proper error messages, because this will be not SFINAE again. So let's try one more thing. C++ exceptions. I can throw an exception, right, in all of those cases. However, this doesn't work, because again, I try to instantiate the return type, and it is a problem. And moreover, this is not evaluated compile time if the argument is not a compile time, so it sucks. But what I can do, I can move those checks to an external function called in the requires clause here. So this is only called at compile time, always, while evaluating the requires expression, the constraints of my interface. So instead of doing this in the body of the function, I just leaving 2unit here, the only check for unit, and I put all of the checks in requires expression here. Requires clause, in this case, right? And I put throw here. This is already somehow better. This entire code, entire error, and it says that substitution failed. This is not a valid expression. So I see what user wanted to actually say, that conversion from is not preserving. So it's a bit better and quite short. With Hanna Dosikova proposal that was accepted in C++26, actually we can throw exception at compile time, and it will end up with an error when it's not caught at compile time. And this is entire error message that I can get. No magic member function for call to in, because constraints are not satisfied, because function safely convertible throws an exception, with an exception conversion from meter to kilometer is not value preserving for int representation type. I would say ship it, right? It's really, really nice. It may not provide exact information why the fail checked, but if you provide the text properly, possibly in multiple lines, then I don't see the reason why it should not be used. However, again, if I try to do this, it's not SFINAE-friendly. What we can do, we can write a wrapper called non-throwing that will just take a predicate called try, func, catch, return false. And then I can do branch instead of using requires expression here. I can just check not throwing and pass this predicate that is being used to constrain a function I'm trying to call. And this will throw an exception at compile time, catch the exception at compile time, and return false instead of hard error, which is an improvement because it starts to be SFINAE-friendly, but That's not most user-friendly. I claim that proposal, this one, has to be extended, fixed for C+26. I will provide the defects report in the national body comments, asking to make it SFINAE-friendly. Because this is the only solution we have, as I am aware of, to make nice error messages in compile time. That will be SFINAE-friendly. So right now, standard says that if substitution to determine whether an atomic constraint is satisfied encounters a substitution failure, the constraint is not satisfied, regardless of the presence of a negation operator. So basically, if substitution fails for constraints or concepts check, something doesn't compile, you get a false, not compile time error. This is what it states. In concepts context, it requires close context. This should be basically extended with all results with an exception being thrown. This also results in substitution failure, and then you are fine, right? Instead of a hard error. And then all of those things, all of this will work and be SFINAE-friendly, and we will be able to have such a nice and short error message to the users. I think it will be awesome. So hopefully it will get to C+26. If not, we have to wait for C+29, because I will write this paper anyway. Because, as I said, I don't see another reason, another possibility to make nice error messages. Because static assert is not a solution. Compile time printf are not the solution. The only thing that remains is throwing an exception. And also, what I'm throwing, actually, is invalid unique conversion. Thanks to another paper from Hannah, all of the exception types right now, standard exceptions, are compile time friendly, so I can just inherit from invalid argument, and I'm done. Hannah did really great work here and provided plenty of context stuff, but we have maybe to fine-tune this one bit in order to get better compile time error messages. All right. Next thing, improving safety. I will not talk much about safety because I said this is subjective, but I have one feature in mind that I would like to mention here. And this is preventing truncation of data. Truncation of data may be considered a safety issue, right? And this is important. Chrono duration basically treats floating points as value preserving, and I'm doing the same so far. So floating point representation type is considered value preserving in my library, as I stated this several times, but this is not the best, basically true. Actually, it's not true. This is a lie, right? Conversion from floating points to floating points may truncate. Conversions from ints to floating points may truncate. This is actually not true to actually state this, but this is what we have as the best possible solution as of today. Right? So what I have in my concept, value preserving is when destination type is floating point, or in case source is not a floating point, but has integral conversion factor, which we've seen already in some of the error messages. And this is not only the thing that I recognize here, also Klaus Igerberger, in using C++ like 2 weeks ago, provided this slide, saying that he actually introduces concepts here, same as of double, to prevent conversions here, instead of putting double here, because he don't want to have truncation of data. Or he said, you can write this one, but it's not easy by yourself. So not only me. Also, SIMD proposal that is accepted for C+26 explicitly says that the conversion from arithmetic type U to T is value preserving if all possible values of U can be represented with the type T. So we have this term already in the standard, but we don't have a type trait that can allow us to check it. And there is a type trait. Sorry, paper 2509, and this basically provides a type trait is value preserving convertible. But it's abandoned for many years, didn't have any revision. So if you would like to help here, it will be really, really needed for many, many libraries, numeric libraries, to provide better, safer interfaces to the users. Let's talk about text. This is simple legacy C++ program, right? Everyone written program like this so far. We have streams for input, output. We take your name and we print it. And this is modern version of it. All right? I see this confusion in the room. Is it really? Right? Still string usage. We have no better ways to do it in C++ as of today. Right? We have IO streams. We have default construction followed by assignment. No error handling. It's not the best code to write. So there's a really nice proposal by Elias called text parsing. He's writing on a library called scanlib, which is really similar or the opposite version of fmtlib, which prints his scans, right? And you can do this. You can do scan prompt, say results goes to string, depending what's your name, and want to read one thing from the input. Taking the values, unpack it to name, and print the name. In case there is an error, values will throw an exception, because this is expected basically under the hood. Or if you don't want to have the exceptions, you can, of course, check if the result is OK. Then you can take the values. Otherwise, you can print the error with the error message from expected, which is nice. Another really nice proposal that is progressing and will allow us library vendors to provide better results. So, for example, I will have text input for my quantities and units. So you can parse some files in order to take the values from text files. But some things are actually embarrassing for C++. Like, it's 2025, and we still don't have standardized tools for Unicode or internationalization at all in the library, right? There is some work on Unicode, but I'm not aware of any work done on internationalization, which is quite embarrassing for a programming language. In case you care, in case you are interested in this subject, please provide some proposals or basically advertise that you're working on something, and we can work from this point together. Last but not least, I'm going to talk about libraries, right? And libraries are for users, and users want to get our libraries at some point. So how you can improve distribution and consumptions of the libraries out there? There's a really nice proposal that is led by Diego and other guys called CPS. Common description specification for packages. I don't know how you feel about CMake. With time, I started to appreciate this thing, but it's an interesting friendship with CMake and me. But I always hate when I have to write config file by myself, which will be actually correct, because writing incorrect config file is really easy, but writing correct one is actually much harder. And when I have to make sure that I install all of the version files and I install this config file, it's messy. With the CPS proposal, basically, all of this will not be needed. You will just write install package info for MP units and export all of the targets there. That's all you have to write in CMake when this proposal is accepted or done. Because I'm not sure actually if we accept it, because I don't know if it actually gets to the paper, but we have to agree on something in the industry. Also, sorry, Diego, but another thing that I hate about package management is package info in Conan. That it always has to be consistent with my CMake files, and it always is not, because I forget, because I add one warning on one fix to CMake, and I forget to update package info. And package info in Conan, if you don't know Conan, is responsible for being able to generate config files for CMake or other build systems from the Conan file sources. If you're all on CMake world, then package info doesn't have to exist, because you will just provide those files generated from CMake to everyone. But not everyone uses CMake. Some people are using something else. So Conan is great, and Conan, based on this information, can generate config files for their build system based on this information. But it means I have to duplicate the information to my CMake, because I'm using CMake, and to Conan for all other users when they actually consume my package. And keeping this consistent is really hard. And loss to type, as you can see. After, we'll just be able to say package info, just load the information from CPS, and this is all. And CPS will be generated by the CMake during build. And even in the future, I will not have to mention package info at all, because it will be the default. So if you don't spell it, it will be the default. It will just take CPS and load it. You don't have to remember about existence of package info anymore. So how it works? Today, if I install with CMake, I get all of those includes somewhere, and also I get libcmake MP units, and I have config file, version file, targets file, with all of the definitions by CMake. With the new CPS support, I get not CMake by CPS, and in CPS, I will just get the CPS definition of my library. And the content of CPS is just that. This is a JSON file providing all of the targets you have with some specifications here. Of course, this may be still incomplete. This format may change because the work is ongoing on this proposal. There are probably some bugs here with this new, but this is work in progress. I think that the deadline is, or the basically a target as of today is CPPCon this year to be ready. I don't know if Diego can confirm that, but this is what guys are trying to achieve. And this is something awesome. If you be able to use those CPS files for advertising our packages, our dependencies, and then CMake will be able to consume them because CMake will actually use this CPS file because, well, there are no config files anymore. Based on CPS, you will be doing find package, and you will just get the package from CPS file. It's so much easier. And interop between vendors will be like CMake, Bazel, or other stuff will be really nice. That's really, really great work. Hopefully, this year we will see first releases of that, which is really nice. All right, to summarize. C++ is awesome. It's probably the best language to implement fast generic libraries. I don't know a better language for that, right? Rust is nice, but it doesn't have even variadic templates. We have zero-cost abstractions thanks to templates, both for runtime performance and memory usage. Constrained concepts improve interfaces. Contracts improve safety in interfaces as well. Reflection will change the world in C++. Right? But some things are still ongoing, some smaller stuff, some things that are still in pipeline, some things that, well, even didn't have a paper so far. In case you are interested in something, if there is something that you care about, please help. We need your help. We need to progress things. We want to make C++ even better for everyone, including library developers and their users. And thank you. With that, I'm done and open for questions.